In the second example, we have to find the so-called cubic roots of or third roots of unity, which means we have to find every solution to the equation w cubed equals 1. So just like I did before, I will write the formula. First, the general. The formula, as usual, is the nth root of any complex number can be calculated as the nth root of its modulus times cosine phi, which is the argument, plus 2 pi times k divided by n plus I sine phi plus 2 pi k divided by n, where k is an integer between 0 and n minus 1. In this particular case, we are calculating the cubic root of 1, but to write the rest of the formula in this particular case, we have to find the polar representation of the complex number 1. So let's draw this too. There we have it. We need the magnitude of this vector representing the complex number. Well, the magnitude is 1, because the absolute value of 1 is in fact 1. And the angle between the vector and the positive half of the real axis, the horizontal axis, is in this case 0. So phi equals 0. Now I can continue on with my formula. So the cubic root of 1 equals cubic root 1 times cosine 0 plus 2 pi k divided by 3 plus I sine 0 plus 2 pi k divided by 3, and in our case k can be 0, 1 or 2. So we expect to get 3 solutions, which is in accordance with the fundamental theorem of arithmetics. So all we have left is to calculate these values. So first, the k equals 0 case, k equals 0 will yield us w0. The cubic root of 1 equals 1 times cosine 0 plus 0 is 0 divided by 3 is still 0. So cosine 0 plus I times sine 0, which can easily be calculated. Cosine 0 equals 1 and sine 0 equals 0. So this number is 1 plus 0 times I, for short, 1. And we have kind of expected the cubic root of 1 to be 1, among other things, of course. Second case, k equals 1. So w1 equals 1 times cosine 0 plus 2 pi divided by 3. So 2 pi over 3 plus I times sine 2 pi over 3. And this can also be calculated. The cosine of 2 pi over 3 is 1/2. The sine of 2 pi over 3 is square root of 3 divided by 2. So this complex number is 1/2 plus square root 3 over 2 times I. And the third root, k equals 2, w2 equals 1 times cosine 0 plus 2 pi times 2, which is 4 pi over 3. So cosine 4 pi over 3 plus I times sine 4 pi over 3, which can also be calculated. The cosine of 4 pi over 3 is negative 1/2. The sine of 4 pi over 3 is negative square root 3 divided by 2. So this is negative half minus square root 3 over 2 times I. And if I draw these complex numbers into my previous plot, well, the first cubic root of unity is 1, just plain old 1. The second one is somewhere over here with a magnitude of 1, and the third one is over here. So as you can see, I grabbed this vector, the first vector, and started to rotate it by 2 pi over 3. This is how I got the first one, and I rotated it a little more with again 2 pi over 3. I got the second one, and if I rotate it even more, then I get back to the start, and it goes round and round. So this was the second example, and this concludes the additional material for the second presentation.